My name is Laurel Haas, and I'm really honored to be here today. I recently attended a DNA study group. Now, I actually have been working with DNA for quite a long time, but I took this opportunity to learn how to really officially document it. So genealogy or DNA is a powerful form of evidence for genealogical projects. So you can use it to help you break down brick walls, to just extend your lines, or to analyze a non-parental event. I'm going to present this within the framework of a research process. So I'll briefly cover the research process, and there'll be a lot more information about that in the syllabus. So if I go through that quickly, don't worry, that'll all be covered in the handout. Then we'll go on to talking about an overview of DNA, so the different types of DNA and how they're used, the testing companies, and then how to analyze specifically autosomal DNA, which is what we're going to focus on today. And then I'll briefly cover a case study for a mystery match, and we can finish with Q&A. All right, so I became a genealogist because I took a DNA test, and I took one originally to learn more about my ethnicity, but then I discovered all these wonderful DNA relatives, and my mother had been adopted. And unfortunately, she had passed away by the time I discovered this knowledge, but she was born in Los Angeles officially in 1924, and she was brought home one day by her father as a gift for her mother. She was never officially adopted. Her mother had a child in Seattle that had died, and then they moved down to LA. And apparently George Olhausen, who was her adopted father, brought her home as a gift. We knew very little about her biological parents other than her mother was a nurse. These are the Olhausens. So this is the family that adopted her. So she is the baby being held by George. She absolutely loved her father, George. And then her mother, Thula, next to her there, and then cousin Thula as well. When I was researching my mother's parents, so I was able to identify my mother's parents with DNA, and I started with my mother's father, and he came from a very large family that moved out to Los Angeles, also from Indiana, I believe, back in the early part of the 20th century. But anyway, the family genealogist for this family, I was in contact with her. She suggested that I find an adoption announcement for my mother. And so I looked in the newspaper. I didn't find an adoption announcement, but I did find an article about my grandfather being kidnapped by bootleggers, which was a very entertaining series of articles that I was able to find. So there he is in the center there, looking very innocent, surrounded by gangster types. The language in the article sounds like an old gangster movie, and he was actually forced to write a letter with a revolver at his head, for ransom money. But he actually was arrested for bootlegging himself a few months later. So. But anyway, so back to the DNA. So after learning I could identify my mother's parents, my task was to find my maternal matches. Now, at this time, today, if you go into Ancestry, you can identify your maternal and paternal matches very easily. They do that for you. At the time, they didn't have that feature. But I was fortunate to have my paternal side, a cousin on my paternal side had done DNA. So I was able to isolate, the paternal DNA matches and then the maternal DNA matches. And, from there, isolates, I really had to go through each match and try to identify who they were related to through their trees or through using shared matches. I also worked with some charts. So fortunately, a lot of this information is plugged into DNA Painter. So you don't need to use a chart, but this chart shows you levels of centimorgans. So you share centimorgans of autosomal DNA with your DNA relatives. So this chart shows me different relationships that are predicted based off of different levels of autosomal DNA. And there is the the average there in the far left column, and then the percent of DNA that you inherit from that particular relationship. And then there's the range of average. So this is what I used. I used this information to identify each match and what relationship they were to me. And what that does is that's going to allow you to identify the most recent common ancestors. So again, I used a chart at the time. I used something called the cousin chart or the cousin calculator. So you can reference a particular relationship and identify what ancestor you share. And as I mentioned, I just completed a DNA study group. It was with Nicole Dyer and Diana Elder. And we use this term MRCA in our class. MRCA is the most recent common ancestor. So identifying that relationship and then going into their tree or researching that DNA to match to find out what is your most recent common ancestor is the next step in this type of analysis. So you can see here, if you have a second cousin, you share a great grandparent. And then you also have the removed relationships. So you have, the relationships of cousins that are older or cousins that are younger, and then that's going to change the ancestor that you share. All right, so after identifying those DNA matches and evaluating them, the next step is to look at their trees, find that most recent common ancestor. But trees, as you probably know, by themselves, they're a source, but they're not evidence. So you want to make sure to use evidence to confirm that those trees are correct. So you can start with census records that are going to show you the household group. And then, of course, vital records, depending on the time frame, can show you who the parents are and help you validate those trees. Okay, so I'm going to briefly take you through the research process, and I'm going to talk about this DNA research within this framework, and then we'll get into the DNA analysis itself. We are going to start by setting an objective. So you've probably heard this many times before, but it's always a good idea to define your objective before you start research. Include key facts like who, what, when, where. So who would be, in my case, Sarah Coates, my third great grandmother. My objective of the research is to document my lineage, including my genetic connection to my third great grandmother, Sarah Coates. And she was born 1823 in Indiana, and she died in 1876 in Greenwood County, Kansas. So, perhaps your objective might be, in my case, I'm proving a genetic connection. Perhaps your objective might be, my hypothesis is that my third great grandparent is Mary Smith, and I'm going to use DNA evidence to prove that, as well as genealogical documentation. Okay, so after you set your objective, and going back, the key to that objective is to stay on this, right? Because often as genealogists, we like to follow, or we like to go down rabbit holes. So this helps us stay focused. All right, so next we're going to review all the prior research that we've done. So if you're not keeping a research log now, I highly recommend it. That way you won't do the same research twice. And that way you can put projects aside and you can come back and read your notes and catch up. So in this case, I had done some basic research on this line, and I compiled all that information into a research log. So my research log contains different columns like the record type and the location of the record, the repository, the link to it if it's online, the date, and then I have a source citation, and then I have all the information extracted. So I can sort this information, and I actually have this in Airtable, which is a really nice tool where I can set up different tabs and link them together and create different reports. So I can actually use this to create a timeline. So, as well as your genealogical documentation, make sure to record, any oral history and any DNA reports. And if you're curious how to cite DNA reports, I'm going to show you some examples in a bit here. And then create a timeline, and that's going to help you see where the gaps are in terms of your research plan. I recommend doing locality and migration research. So, again, if you're researching in a particular area quite a bit, this is a great resource for you to put together for yourself. So, um, you can start with the Family Search Wiki, Google Family Search Wiki, and the name of the place you want to research. So whether that be a country or a county and a state, and it's going to provide you with a lot of good contextual information that's going to help you interpret your results and also find the best record sources for your research. So historical events, boundary changes really have a big impact on the records and where you're going to find them. Religion and economics impact migration. County histories or local histories are also very helpful to provide this type of information. Laws impact records. For example, how old do you have to be to start paying taxes, and when can you expect to find somebody on a tax list? Geography maps, migration routes, and then, of course, the sources of records in that area are going to be really helpful for you to know about. In this case, this particular family, so this was Solomon Fennis and Sarah Coates. They actually were mentioned in a local history. So I was fortunate to find out exactly how they migrated from Indiana to Kansas. So they took a journey by ox team in 34 days from Hamilton County, and they went to Breckenridge County, Kansas Territory about 1855. And Kansas at that time was called the Kansas Desert. And in the 1840s and the 1850s, Midwesterners, especially from Indiana and Illinois, were beginning to settle there. So they were part of that group. I continued to research this family all the way down to my grandmother. And so my great-great-grandmother, who was the daughter of Sarah Coates, who were proving with DNA evidence, her and her family moved to Colorado. And then I, through newspaper research, found out that Sylvester Roberts, who was her husband, had put in a permit for a homestead, but then about 10 years later, he had moved to California. So I'm not sure if he got that, but I also learned from the newspaper that he was a citrus rancher. So at this particular time in California, which would have been, right at the turn of the 20th century, citrus farming was growing. So once I review all that, my research review, what does my research review and my locality study tell me about my objectives? So, in my case, I knew I had 19 good DNA matches. So my hypothesis was, I'm setting out to prove this relationship by going through and analyzing these objectives. Your hypothesis might be about where you're going to find your ancestor. So it can be different things based off of what you've learned in your review of research. Okay, so now you're going to put together a research plan. So you can put together a research plan of traditional genealogy sources and your DNA tools. So in this case, I want to document the birth of each child of Sarah Coates, and I'll use a variety of different records. I'm also going to look at Kansas Memory to see if I can find any biographies online. And then I'm going to work with some DNA tools. So I'm going to use Ancestry thrulines to identify shared autosomal CMA with top matches to each child of Sarah Coates. And then I'm also going to use the shared CM project to evaluate the relationship for each match. So research plans are a great idea. Again, like the objective, as much as possible, you follow the research plan. They do change because sometimes you will find things that are critical to your research or to your objectives. So research plans can definitely change. And then the fun part is collecting and analyzing data. So you're going to follow your research plan. You're going to record your findings in your research log, and you're going to include research entries for DNA analysis. And then you can write and cite your findings. If you're using a research log, you can just copy all your results and comments right into a document and start up a report. And you can write as you research. And then if you're going to publish this, you'll want to cite all genealogical facts and DNA findings, but you want to make sure to mask all living people's names. So even your DNA match screen names, I would recommend, I think you should mask them based off of the genealogical proof standard. And I do have a little bit of a summary of that in the syllabus. in case you're interested. Okay, a couple examples of DNA citations. So these are for reports, and the format's pretty similar, actually. I have the name of the report in quotes. So for example, if it's a DNA match report, my citation is, my name and the name of the person, or maybe private, where that report came from, in this case, Ancestry DNA, and then I can include the link and the date I accessed that. And then just some information about what I found. So this particular DNA match is a predicted second to third cousin. We share 209 centimorgans of DNA across 18 segments. So that is an example of a citation for a DNA report. And if you look at the other examples, the Thrulines report, DNA Painter, the format's really pretty similar. It's a report title, a company, and then some detail after that. So we will finish with making a list of additional research questions. So as you're going through your research, if other questions come up that aren't relative to your objective, you can jot those down, and those can become part of your new research objective. And then you're going to write your conclusion, where you're going to state whether your research objective was or was not met and how. So you're going to summarize what you learned that addresses the research question. So that's a quick review of the research process, and now we're going to talk about DNA. So as you probably know, strings of DNA are coiled into chromosomes, which are in the nucleus of most cells. So there are 23 different pairs of chromosomes in each cell. So there's the sex chromosomes, and then there's the X and the Y, or the X and the X if you're female, or there are the 22 autosomal chromosomes. So when we, most of the time, or the most common type of DNA testing is autosomal. This is the type of DNA that we're testing, and you'll see these little colors on these particular chromosomes represent segments on those chromosomes. So we won't get into segments today, but I'll talk about them a little bit. So a centimorgan is a metric used to describe how much DNA and the length of genetic segments shared with your relatives. So you receive 50% of your DNA from each of your parents, but not necessarily equally. So, if you look at this example with the building blocks, you can see here's the grandparents, and then here's the parents. And you can see that Edward's just a straight combination of his grandparents here. But if you look at the children here, this person, Gerald, did not, in this example, they didn't inherit any of the DNA from the grandfather at all. Now, that's not likely. Very likely they did. But just to show you an example how different combinations of DNA are going to be passed down to different siblings. Higher levels of DNA indicate a closer relationship. But there are 4 different types of DNA that can be tested. So autosomal, as we just talked about, includes all the chromosomes except the sex chromosomes, and it can help you identify ancestors within the last 5 to 7 generations. So really going back to that 5th great grandparent. You do not inherit DNA from all of your ancestors. Second cousin or closer, you will. But beyond that, you do, your third cousins, your fourth cousins, you may not necessarily share DNA with. A few other types of DNA, and you can get these tested. There's Y DNA, so that is carried only by men and passed down from father to son. So you can compare the Y chromosome of 2 males to determine whether they share a common patrilineal ancestor. So we call this the surname DNA. So if my father had a son, which he did not, he would be able to trace his Y DNA all the way up through the Haas line. Mitochondrial DNA is found in a cell's mitochondria. Now that is passed from a mother down to her children, but only females pass this down. So this is, again, DNA that can help you trace a matrilineal line in this case. The only difference is you will see this in males. They just don't pass it down to their children. So if you're looking at family tree DNA, you will see males with mtDNA that share that a matrilineal ancestor with you. And then xDNA, it's passed down from a female to her children. So generally, if you're female, you have two X chromosomes. And if you're male, you have an X and a Y chromosome. So xDNA analysis is actually most useful for males because xDNA almost always comes from the biological mother. So if you are looking for people related to your biological mother and you're a male, you can find that through your xDNA test. As a female, it can come from any number of females that you're related to. DNA testing companies, these are some of the larger ones on this particular chart. So Ancestry DNA has about 22 million tests. So, and we're going to be working with Ancestry today. Ancestry has the benefit of being connected to all that genealogical information. And, when I first discovered that I could figure out my mother's parents, I had tested on 23andMe originally, but I tested on Ancestry DNA because I knew I could look at those trees and connect things together. 23andMe recently bought by a pharmaceutical company. I think they'll continue to have a health focus, but they still have, quite a lot of tests out there. And, no genealogical information. I was able to get started on my research just by writing somebody, and that's mainly what you would need to do on 23andMe to identify matches. MyHeritage also is great for DNA testing and genealogical information. Not quite as many tests out there at this point. Family tree DNA is unique in that you can do all 4 types of DNA testing with family tree DNA. And you also have the chromosome mapping, which I think used to be on 23andMe as well. I don't know if they'll bring that back, but so you can do a little bit more sophisticated DNA analysis with family tree DNA. And you can also, I believe you can still upload DNA. So you can download your Ancestry DNA and upload it to family tree DNA and use their tools. Also, people do attach their trees on family tree DNA. So you do have some kind of reference point to genealogy information. And the other thing is I do find more European testers on family tree DNA. I found actually a cousin from Denmark on family tree DNA. So that's what makes it a little bit unique, even though they don't have nearly as many tests. And then GEDmatch doesn't do testing, but it is a site where you can upload DNA for free, and it offers some different tools for analyzing it. So I'm going to show you DNA analysis using thrulines, but I wanted to stop for a moment. And in case you don't have thrulines, what I would recommend is that you take a look at the leads method. So this is at danaleads.com. You may know about this, but she shares a method for grouping your DNA matches, and you'll group them, I believe, into the great-grandparent lines, into clusters, and then that'll help you to be able to begin to analyze your ancestry using DNA. So Ancestry Thrulines is a great feature that Ancestry added in several years ago, and it will give you a list of all the ancestors that are in your tree. So when you go into Thrulines, you'll see your grandparents, your second great grandparents, and so forth. And then what Thrulines represents is 2 things. One is you have somebody in your tree that somebody else has in their tree, and they're a DNA match. So Thrulines, again, just like a tree, isn't by itself proof. You need to go through, analyze those matches, and also analyze those trees and prove that relationship. And that's what we're going to go through today. So in Thrulines, you're going to have, in my case, I already have my 3rd great grandmother in my tree, and I'm just proving this. What if you don't know who your 3rd great grandparent is? There's a couple different ways you could use Thrulines. Number one is you could have a suggestion. So somebody else might have an ancestor in their tree that might be connected to somebody else in your tree, and there's DNA relatives associated with that. So there's a hint about an ancestor. And the other thing is you can just add a hypothetical into your tree, and I think you may need to wait till the next day, and it will show up in Thrulines, and then you'll be able to analyze that hypothetical. Now, if you have no idea who your third great grandparent is, then you need to go through and group your matches. So, you can do that with the leads method, and we'll talk a little bit more about how we're going to identify matches beyond through lines as well. So once you click on an ancestor and through lines, you'll see the relationships. So this is pretty straightforward here. Here's my third great grandmother. Here's all her children. And then it's showing me DNA matches that are related to each of her children. So I can click in here and begin to look at those DNA matches, look at their shared centimorgans and begin to evaluate their relationship and whether the amount of shared centimorgans makes sense based off of what the relationship should be to me based off of where we are in the tree here. Do you choose every single DNA relative that's in through line? I would say no. When we were in the study group, we used a cutoff of 25 centimorgans. But what I've read about is that what you should be looking for are DNA matches that share larger segments. Now, the challenge with Ancestry is it's not going to give you a chromosome mapper, so you can't really see, how many large segments a particular person has. But what you can do is you can see the longest segment. And I think as long as it's over 12 centimorgans, so a small segment's considered under 12, I believe, then that should be a good match for you to use. I've started to identify my matches with through lines, and now I'm going to record all them into a log. So again, I have a log here. I have the username, which I have disguised here, and I've just entered how many centimorgans I share with each match, who my most recent common ancestor is. So, based off of that tree, based off of what I know about that person, who's the ancestor that we're sharing in common, and then what is their relationship to me? And we're going to talk about a process for identifying what those relationships are. I have the number of segments in this particular log, but I actually didn't use that in this analysis, just so you know. In addition to using through lines, I also want to look at my shared matches because I'm going to have probably several matches that are not in through lines. And the reason they're not in through lines is either their tree isn't linked to their DNA test. So if your tree is not linked, you won't show up in through lines. They don't have a tree at all. Or maybe they've just started a tree and they haven't gotten very far. So I would highly recommend you look at your shared matches, and you can use certainly those through line matches to find matches in common with those particular people, sorry. And then what you would need to do with those additional matches is identify how they're related and who the most recent common ancestor is. So, if they do have a tree, then you can do that. You can try building a tree. And of course, you can try sending them a note as well. There is a new Pro Tools option in Ancestry. And what this provides to you is for your matches in common, it's going to show you how much they share with your matches. So that's an interesting new element that they've added to DNA analysis. And I'm going to show you an example in my case study of how you can use that, because you can actually use that to help you predict a relationship. So again, this centimorgans here is what this match shares with my matches, not what I share with them, which would be the 225 centimorgans up at the top. Now, if you click on this hyperlink here, once you open up a match in Ancestry, you'll see some more information. And this is where you're going to see the longest segments. So, if you recall, if you want to look for DNA relatives that have a segment at least 12 centimeters or more, this is where you can find that. So now that we've identified all our DNA matches, we're going to evaluate the relationship based off of the amount of shared centimorgans that we share. So this is a screenshot of DNA Painter, and I'm actually going to call it up live and show it to you. So this is DNApainter.com, and this tool is called the Shared CM Project, and this was based off of a large study that was done collecting DNA test information and relationships and using that information to be able to determine relationships with this tool. So this is based off of a database. We'll see a little bit more about it in a moment. But this is really simple to use. So all I want to do is I want to go through all my DNA matches, enter in those centimorgans, and evaluate the relationship that is predicted. So, you know, if I'm looking at a family tree, somebody's predicted as a third cousin or a second cousin, I can go in here, just type the shared centimorgans in, and it will predict what relationship they could be. So I had a mystery match that I share this 225 centimorgans with. And if I enter that in, it predicts, you know, in the top percentage. So this is the highest percentage of the people in the database. You know, this could be a second cousin, a half cousin once removed, a cousin twice removed, you know, and you'll know, you know, based off of their relationship to you, where they fall in terms of this particular relationship. So, you know, you may not necessarily always find a DNA relationship in this highest percentage here, which is okay. Let me see, let me bring this other chart up, which disappeared on me. There it is. So for example, if I click on a second cousin here, so this particular chart is color coded. So this is showing that these particular relationships, what ancestor they would share with you. So if I have a second cousin, they're sharing a great grandparent. I'm going to click on second cousin. That's an average of 229 shared centimorgan. And this is going to show me my amount of DNA that I plugged in and where that falls, you know, on this particular chart. So it falls in the largest group of cases. And then it's going to tell me how many submissions there were in total for this relationship, the mean value, and the standard deviation. So one tool that we use that was a little bit helpful for evaluating these relationships is that standard deviation. So as long as you're within one standard deviation of the average, you can probably be pretty confident of the relationship. And one of the things I found was that in generations removed younger than me, that they tended to share less DNA and were more likely to be in a lower probability relationship. So yes, you're going to go through all your DNA matches and enter in those centimorgans, and then you can record the predicted relationship. And then your next thing to do is place your DNA match into the family tree. And I just wanted to see if you're awake. That's why I put the Star Wars chart up here. But anyway, here's my family tree. So now that you know their relationship, you may have their tree, you may not. But hopefully you're able to, at this point, place them in your tree. And then you can actually link the DNA match to that as well. And once you add all your DNA matches to your tree, there's some tools that you can use that also can help you evaluate relationships for more difficult matches. So this is a good idea to do. You know, again, disguise the names of living people, you know, if you're going to publish anything. So now that I've gone through, I've analyzed all my DNA matches. I've identified who they're related to, their relationship. I've put them in my tree. And so now I'm going to write up my findings. And what I did was I created a table for each descendant of my ancestor with a list of matches. So all of Sarah Coates' children that we saw on that thrulines chart a few slides back, I created a chart for, and then listed all their children and then the matches underneath each one.
Laurel, sorry,
yes.
We're still seeing your DNA painter screen.
Oh my goodness. Okay. Okay, so you didn't see my funny slide. So there it is. There's the Star Wars family tree. Oh, you know, I just totally ruined that joke. Foiled by the screen share. All right, yeah, so you want to place your DNA match, each of your DNA matches into your family tree once you've identified that relationship. And then you're going to write up your findings. So as I was referring to, I put together a table for each child of the third great grandmother that I was researching. And then I have here a column for each child, and then I have the matches listed underneath each with their relationships and the amount of shared centimorgans. And you'll notice I have all of those sourced with a DNA report or a DNA citation. and just make sure to mask living people's names if you're going to publish. So now I'm going to go on to show you a quick case study of how I've identified a mystery match. So as part of this project, I had a match who I shared a fair amount of DNA with, 225 centimorgans. They had no tree attached, and I had no idea how this person was related to me, but I really was curious, so I decided to research this. So this is an example of how you can build a tree and figure out how to identify a mysterious match. Okay, so first I had to identify this person in genealogy records, and fortunately, her DNA name was her name, so I was able to look her up. She spelled her first name a little bit in an unusual way, so that was helpful. And then her husband's last name wasn't super common, so I was able to find a marriage announcement with the names of her parents, and then the California Birth Index to find the name of the maiden name of her mother. And then from there, I was able to figure out who the grandparents were. And so based off of that level of DNA, that 225 centimorgans, I'm looking at those grandparents and where they came from, because my prediction is that she was in a generation older than me, and that she was, potentially a first cousin once removed, or a half first cousin once removed. So I needed to identify her grandparents, and I was able to do that. And I found one set of grandparents had come from Salt Lake City, and the other set had come from Colorado. Well, my family had migrated to Colorado. The daughter of Sarah Coates, Nina Roberts, had migrated there with her family. So I created a timeline and compared the two families to see if I could figure out what was going on. And what I found out was that her grandparents were in San Miguel County, Colorado in the year 1900 on the census. And one was a boarding house keeper and the other was a boarder, but they were both single. And then in the same census, my family was enumerated with 4 children who do not match on name or age with their children. So for some reason, they had an odd census, and I haven't solved this mystery yet, but they were in El Paso County, Colorado, which is a good 300 miles away, but they were in the same state. So I continued to look at this, found out that the mystery match's mother was born on the 10th of October in 1900. And then her grandparents actually married in 1901. So after that, in San Miguel County. And then my great grandparents married in Colorado Springs several months later. And then by 1910, they were in Los Angeles. And my grandmother was born. While this particular family did stay in San Miguel County, and eventually they moved out to California as well. So it seemed like logistically something may have happened here. Maybe, maybe her mother was adopted. In terms of the birth date, it came from the Social Security Death Index. If you look at all the different census records, they don't agree on birth year, but perhaps, her mother was born out of wedlock and was adopted and was somehow connected to my family. Okay, so what I did next was I evaluated the DNA that my mystery match shared with my other matches. So if we go to this shared matches page again, you need Pro Tools for this, but you're going to be able to see how much this match shares with your matches. And you'll be able to use it in this tool called What Are the Odds? So in What Are the Odds, you're going to import or build a tree with your DNA matches. So, having those DNA matches added to the tree certainly helps with this analysis. You're going to enter how much the match shares with other matches. And then you're going to predict a relationship for a match based on how much they share with other matches. So I will do the screen share properly this time. So this tool is called What Are the Odds? And you're going to enter the name of the person you're trying to place in the tree. So we're trying to figure out what relationship this person is who we have no idea who we're related, how they're related to us. We're going to enter their birth year. So I was able to find that on the birth index. And that is why I know, the generation. And then you can enter the research question. And next, you can either build or load a tree. So there's a little box here that says most recent common ancestor or couple. You can add a child. So let's say this is Sarah Coates. I'll click Add Child. There's her daughter, Nina. I'll add another child. Here's Hannah. Here's her daughter. Here's my mother. Here's me. And you can keep adding into this. So you can keep adding more children. You can add the rest of her children, their children, and so forth. And then for the DNA matches that you enter on here, because you're going to enter them on this particular family tree, you're going to enter the match CM, and that's going to be the amount that that mystery match shares with that person. So if this is me, this is 225, I'm going to add other people here, and I'm going to enter in the amount that that match shares with those people. I'm going to clear this out and show you another way to do this really quick. So I'm just going to load a GEDCOM. So in Ancestry, for example, you can export a GEDCOM. Actually, you can generate a GEDCOM from tree settings, and then you export it after you generate it. And then you can load it right into this tool. And the really nice thing about it is you can type in the name of the most recent common ancestor. So that way you don't have to create a special tree or anything like that. The other thing is it has some tools here that you can use with other kinds of DNA. So if you do want to do xDNA testing or mitochondrial DNA, this will help you identify just the people that could be descended with that type of DNA. And then we're going to replace the names of living people with their initials, and then I'll just hit import, and there we go, voila. So now instead of having to build that tree, I can just go in here, enter in the CM for each of my DNA matches. And then once I'm done with that, I'm going to click on suggest hypothesis. So I'm going to show you what this looks like over on my chart. So this is an example of a what are the odds analysis, and what it will do is it will develop hypothesis of what relationship this person is in the tree or where they should be in the tree, and it will give each one a score. So this particular analysis for some reason did not account for the generation, so it placed her in the wrong generation, but that's okay. It suggested that she would be a child of sibling of one of my grandparent siblings, my grandmother's siblings, which the other thing that I'm not sure if you can account for it in Watto, but there is also the DNA that's shared with her husband, which this particular match does not share. So this match does not share DNA with Hannah's husband, therefore she cannot be what the highest score hypothesis was, and that was another great grandchild of Hannah Roberts. Now, the second highest score, though, was that unknown half sibling. So, my hypothesis based off of this analysis, based off of the Colorado analysis, is that this particular match is the granddaughter of Hannah Roberts and, an unknown father. Now, I did try to contact this match, of course. I've written them a couple times, but I've totally disguised everything, even the names of her parents, because certainly the sensitive nature of what I may have discovered here. And she may or may not know this, but that is not something that I know. So we talked about the shared matches, and again, this Pro Tools is what you're going to use in that what are the odds tool. Watto is what I called it. The amount of centimorgans that your match shares with your other matches. So to finish up, I recommend that you follow a research process for best results. You can analyze DNA for 5 to 7 generations back. You can identify autosomal DNA matches using tools like thrulines or shared matches. Choose predicted second cousin matches, and then additional matches by identifying matches with long segments shared for third cousin or higher. Evaluate the relationships for each match and identify the most recent common ancestor, and use genealogical documentation along with DNA to prove relationships. And then you can use tools like what are the odds to predict relationships for unknown matches. So here's Nina Fennis Roberts and Hannah Roberts Todd and her 3 oldest children, including my grandmother, the gal with the pigtails. And with that, I'm ready for questions.
So the first question we have, this person says, my father took both ancestry, autosomal, and Y DNA tests, He has a few matches in the X column. His maternal grandfather was adopted and died as a young father, and nothing was known of his parentage. So she asks, can we use those X DNA matches on family tree DNA to figure out biological parents?
Well, what xDNA will help you identify is his maternal line. So those are going to come from a female ancestor from his mother. So it could be, his mother's. If we go back and look at the chart, it shows you all the different ancestors it can come from, but it would help you identify your mother's line. Yes.
So when documenting DNA evidence, how do you kind of balance technical explanations and then creating some clarity for readers? How do you handle that?
I think, it's a really good idea when documenting to assume that the person reading it doesn't know anything about DNA. So I would recommend, a brief explanation of the type of DNA that you're using, similar to what I provided here. And then, you can explain the process of your research and how you're evaluating it. Again, similar to how we did that here. Does that answer the question? Is that helpful?
Yes,
Okay.
thank you. And another one we have is, have you ever had to revise your conclusions when working with DNA after you've had new matches appear or different testing was done in other cases?
Not yet, but well, actually, the very first DNA analysis I did was about my mother's father, and she came from this very large family. There was a definite match to a great grandfather with something like 12 children, and I had to go through the relatives of just about everybody had done a DNA test to um, identify who of these 12 children. So, I think in the beginning I was doing a lot of process of elimination and not as much DNA analysis. And I think learning the DNA analysis aspect of it helps me get to those conclusions more quickly.
Thank you. And it looks like we have one more question. They're asking, can you still do this if you only have two or three decent matches to that ancestor and get reliable results?
I think, it's possible. I mean, I would certainly analyze those two or three decent matches, but I think, more evidence would be helpful. It kind of depends on what the relationships are, and what generation you're looking at. But if you're looking at, yeah, I think third great grandparent, I think you would probably want more than two or three matches.
Thank you. And I lied, we do have one more after that one. So this person's asking if you could please repeat what you said about the longest segment importance. 12 centimorgans or more in length suggests a good possible match. They say I have a match which is 20 centimorgans, who I'm trying to connect to a third great grandfather.
Yes. So I looked at some information on length of segments, and I believe 50 centimorgans, I always want to say centimeters, centimorgans or more is considered large, and then 12 to 49 is considered medium. So I believe that should be a good, especially if it's overall the amount of centimorgans is, 25, 40, something like that, or more. I think that
Thank
should
you.
be fine.
Thanks. So I think that'll finish us up for questions this evening. Did want to mention if anybody would like a copy of the chat or if you have additional questions, please send us an email at genealogy@acpl.info. And thank you again so much, Laurel, for presenting, and thank you to everybody for attending. So, good night.
It has been my pleasure. Thank you so
Thank
much.
you.
All right.
Bye-bye.
Bye-bye.